Thank you very much for the opportunity to talk about the DADA2 case in China. I'm Qing Zhou, an investigator at Zhejiang University. Since our first 3 DADA2 patients identified in 2012, it has been 8 years, and hundreds of DADA2 has been diagnosed. Till now, DADA2 cases have been identified in more than 6 provinces in China. 3 papers have been published reporting 7 DADA2 cases in China, and they all have typical DADA2 presentations. We also have diagnosed 14 DADA2 cases. Let me share with you several interesting cases. This is a case of a 7-year-old Chinese boy who presented with a history of libido rash and recurrent fevers that began around 1 month of age. He had an ischemic stroke at 2 years old and another at 8 years old, followed by a hemorrhagic stroke at the same year. So his clinical presentation is typical DADA2. The whole exome sequencing identified 2 missense mutations in ADA2, R169G, which was inherited maternally, and G47R, 48R, which was inherited paternally. The compound heterozygous variants were also detected in his 3-year-old sister, who appeared to be unaffected at the same time of testing. However, one year later, she developed a libido rash on her face and limbs. While the R169Q is a well-known pathogenic variant in ADA2, the R169G is a novel mutation. To further determine the pathogenicity of the variant, we overexpress the wild type and the mutant plasmid in 293G cells. Both variants were found to decrease the ADA2 activity in both the cell supernatant and the whole cell lysis. Additionally, the R169G and the R169Q variants were found to affect the secretion of ADA2 into the cell supernatant. I think it is interesting as the variant mutation is not located in the signal peptide, but it affected both ADA2 secretion and activity. The second case is a 28-year-old female presenting with immunodeficiency, hepatosplenomegaly, sinusitis, and bronchiectasis. Whole exome sequencing were also performed on this case. The sinusitis and the bronchiectasis is not common in DADA2. And we identified homozygous G47W mutation in ADA2. The third case is a 6-year-old boy with recurrent fevers, hypertension, and also has a family history of early onset hypertension from great-grandfather. The whole exome sequencing identified the compound heterozygous mutation in ADA2. The enzyme activity assay showed the patient has extremely low ADA2 activity. The father has a carrier level, and including father, grandfather, and great-grandfather, all of them carry the H335P mutation. As the H33R is a common SNP and is predicted as a benign variant, but at the same amino acid, the H33P is a pathogenic because the patient showed the diminished ADA2 activity and the family also showed ADA2 carrier may have some phenotype such as early onset hypertension. The fourth case is also a typical DADA2 presenting with strokes and fevers. The whole exon sequencing indicates a possible homozygous exon 7 deletion in ADA2. The exon 7 deletion or duplication has been reported due to ALU sequence, but our case is a little bit different. The IGV showed the exon 7 is deleted according to the whole exon sequencing data. We also failed to amplify the exon 7 in the patient. The patient has a the patient has a small deletion which deleted the exon 7. This is inherited from the father, but the mother is not the same exon 7 deletion carrier, indicate the second deletion is different. We also performed RNA sequencing. Here, the results show that the patient has a large deletion. The sequence read across from HD5 to ADA2. In order to figure out the large deletion breakpoint, we performed sequencing on both the cDNA and also genomic DNA. After trying many PCR and sequencing parameters to sequence the amplicon, we figured out the patient has a small deletion on ADA2, exon 7, and a large deletion. The large deletion spanned 58 kb and deleted the HD5, exon 1, and ADA2, exon 2 to exon 10. Therefore, from the RNA sequencing and cDNA sequencing, we could see the patient has a fusion mRNA that is from with exon 1 ADA2 to HD5 gene starting from exon 2. This large deletion is also novel and never has been reported. We next aim to figure out the mechanism of the large deletion, whether it's also mediated by the ALU sequence. Here are the lists of 14 DADA2 patients we diagnosed in China. Most of patients have strokes and fevers. The 14th patient with the G47R homozygous mutation mainly presented with a ball perforation due to the ball ischemia. The MAF plot showed the ADA2 mutation are most clustered in the CAD score more than 20, except the H33P mutation. This is the distribution of ADA2 mutation in Chinese patients. We did not see founder mutation in Chinese population. Interestingly, we also identified 5 SLE cases with ADA2 heterozygous mutation. So is it possible that ADA2 is a risk factor for SLE? Of course, to prove it, we need to identify more SLE patients as ADA2 carrier mutation carrier or do more functional studies. In summary, the ADA2 has gained its attention in China, but is not enough yet. Several new mutations in ADA2 have been found in the Chinese patients, but we did not detect a founder mutation. The WES can be applied to find CNVs in the DADA2 patients. And for those DADA2-like patients but are ADA2 mutation negative, there are other pathogenic genes involved in the similar signaling pathway. Thank you very much for your attention. If you need to do genetic testing, please feel free to contact me.